Quotient law. Next one. Da-na-na-na. Okay, look. Remember, this fraction sign means subtract exponents. X to the m, subtract n. Okay? Watch. Really simple. Okay, x to the 5, x to the 3. Remember, that means subtract the exponents. So x to the 5 minus 3, which gives you plain old x squared. Ooh, tough. Look at this one. Okay, again, subtract the exponents. This would be 7 to the negative 5 minus 3, which actually gives you 7 to the minus 8. Now, remember, we don't like negative exponents. Blech. So, flip it, change the sign. 1 over 7 to the 8. Now, unless it says evaluate, which it doesn't here, it doesn't say evaluate, just leave it as an exponent, 1 over 7 to the 8, because 7 to the 8 is a huge, huge number, okay? So let's go. Look at this next one. Sure, I'm going to throw some weird stuff at you. Look at this. This is 3y. This is 3y. But you notice that they're both in brackets? Look, let me erase that. Look, they're both in brackets. So guess what? This is like taking a box and dividing it by another box. They're the same basis. The bases are the same. So remember, that says to subtract. So this is 2 minus. Now, here's where most students get caught. This is where most students get caught. They forget that this is a minus 6. So you actually have a double negative. A double negative makes this a positive. The answer is 8. So whatever this original thing was, oh, there it is. There's the original. The original is 3y. There's the original base to the positive 8. Watch out for the double negatives. That's what's going to get you. So you know what? I'll tell you something. I'm going to do this question one more time because you need to see it. Okay? You need to see it. Watch this. When you're doing this question, remember, that means subtract the exponents. So we got 3y to the power of 2 minus a minus 6. That's so important to show that step because you would not believe how many students will tell me that is 3y to the negative 4. It drives me crazy. Negative, negative, remember, becomes a positive. So this is actually 3y with the brackets, yup, to the 8. Don't get messed on that. Okay, onwards. Let's look at this one. Okay, well, same noise as before, but now you got a fractional exponent. Now you got a decimal base. Turn it into fractions. Fractions are so much easier. Look, 0.5. Remember, that's in the 10th spot. So guess what? This is 5/10, or look at that, 1/2. So this is, there's the subtraction. This is 4 to the 1/2. Subtract the bottom, which is also 1/2. Oh my goodness, okay, which gives you 4 to the 0. Do you remember? That's 1. Oh, that turns out actually kind of cute. Okay, let's do this one. Now, remember, that means subtraction. So this is 1.5 to the 4/3 minus 1/6. Well, you know what? Common denominator it, folks. Okay? Look, I'm going to do it like if it was scrap paper. I'm just going to do it right over here. Minus 1/6. Remember, to make these guys common, you have to multiply the bottom and the top by the same thing. So this becomes 8 over 6 minus 1 over 6 becomes 7 over 6. Do you see it? So now we can write this here as 1.5 to the 7 over 6. It doesn't say anything about putting it in radical form, but if you wanted to put this in radical form, that would be no problem. Remember, flower power. There's the flower, there's the root. Okay? Flower power says 6th root of 1.5 to the power of 7. Nice, hey? Yeah, those fractions, don't let them scare you. Look at this one. Interesting, interesting, interesting. This one says division. Do you know where the symbol divide came from? The symbol divide came from a fraction. This divided by this. Yeah, numerator divided by denominator. There's your symbol for division. So write this as a division statement then. This is going to be 4/3 to the power of 1/3, right? Divided by 4/3 to the power of 2. Remember, this just means subtraction. So if you think about this then, oh, okay, let me extend this out here. This is just going to be 4/3 to the power of 1/3 minus 2. Now, again, 1/3 minus 2, remember, that has to be converted into a, yep, you got it, into a common denominator. Times it by 3, times it by 3. So this is now 1/3 subtract 6/3, which ends up being minus 5/3. Okay, let's put it back. So here we go. We got 4/3 to the power of minus 5/3. Now, remember that negative. Don't like negatives. Okay, so we flip it, change the sign. Done. Leave it as a power. It doesn't say anything about evaluating it. And if you do have to evaluate, you can go on and use some more of those procedures that I taught you in the previous podcasts, or just throw it in your calculator and it works.